Here and beneath. So, have you ever wondered how gravity is implemented in video games? In today's video, I'm going to answer that one question. Today, I'm going to explain how gravity is simulated in video games. First, what is gravity? So, gravity is a force which pulls everything downwards, that is, towards the center of the earth. So, if there is an object, gravity pulls it downwards towards the center of the earth. This force causes an continuous acceleration, which is in model world 9.8 meter per second. Now, what I mean is that if there is an object with an velocity in the y-axis of 0 at the start, then every second it would be incremented by 9.8 meter per second. That's why the acceleration due to gravity is said to be 9.8 meter per second square. That is 9.8 meter per second per second. So, in the terms of program, if they have an object whose velocity downwards in the y-axis, that would be Vy. So, instead, then there would be an integer value V y, which usually is 0 at the start. That is, the position of the object in the y-axis changes every second by this value. That is, position of object in y direction is added is is determined by this V by variables. So this is done every 6 seconds. And this Vy value is again incremented by this, the value of acceleration due to gravity, which usually in the real world is equal to 90.8. Both of these are each second. So this acceleration due to gravity is constant for not every single object, no matter its mass. So then, by this logic, an object with mass, let's say 10 gram, and an object with mass, let's say 100 kg, should fall at the same speed. Let's say this is V1 and this is V2. Then V1 theoretically should be equal to V2, but that doesn't occur every time in the real world. Even if the values of rose, they are not equal. This is due to the uplift. Uplift is nothing but the resistance provided by the air in the surrounding. That is, the air the object is colliding with while falling down. Before I explain why this happens, let's take two objects of same mass. Let one be a cuboid and other one is a cube, both of same materials, same density. This one has mass h, this two has mass m. So technically, it should fall at the same speed, but that doesn't happen because in the second scenario, the air hitting the bottom of the object is less than in the first scenario. Thus, the resistance experienced by the first object is to be more than the resistance experienced by the second object. And thus, But this is really wild. Improves as it speedily too. To watch one business does improve. Similarly, this is the reason why if a creeper is dropped horizontally like this, it drops gracefully, and it drops when it is released vertically like this. So, okay, and so our first example, they are just two objects with masses on mass empties which have the same shape and size. Which one would fall faster? The one with the greater mass or one with the inputs? So when in one falls faster than in two, well, the answer is in two they fall faster. The reason is the up experience by both of them is equal, but the force that is acting against the uplift is different. Here, M1 force is acting against the uplift, and here M2 force is acting against the uplift. So the uplift would be more effective than in case of M2. And in games which have good physics simulations, all these factors are taken into consideration. I hope you enjoyed today's video. That's it for today, and I will meet you guys in my next video. Potatoes.